Correlation analysis is a statistical tool generally used to describe the degree to which one variable is related to another. Two series of data may show high degree of correlation, but this may be purely accidental or through chance. With the help of correlation analysis, we can identify the direction or nature of relationship between the variables. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 1 of Unit 3, we will have a discussion on correlation and regression analysis. Now first let us see what do we mean by correlation. So if the individual values in one set of data, say X variables, move along with the changes in individual values of another set, say Y variable, two sets of data are said to be correlated. Now we have the variable X and the variable Y. So if this moves, this also moves. So this, for example, income and expenditure. Suppose you have the income here and the expenditure here. Then height and weight, advertisement and sales. An analysis of the study of the relationship or connection or interdependence subsisting between two or more set of series is called as correlation. So, income and expenditure, height and weight. Then we have the advertisement and sales. So, the more the advertisement, more the sales. So, this kind of a relationship existing between the two variables can be called as correlation. So, if two or more quantities vary in sympathy so that movements in one tend to be accompanied by corresponding movements in the other, they are said to be correlated. So, correlation analysis attempts to determine the degree of relationship between variables. So, analysis of the covariation of two or more variables is usually called as correlation. Now, we have the meaning of correlation. Correlation analysis is a statistical tool generally used to describe the degree to which one variable is related to another. So, there are various phenomena which have relation to each other. The theory by means of which, it is a theory by means of which the quantitative connections between the sets of phenomena are determined is called the theory of correlation. Now, theory of correlation is the method through which we can understand the relationship between the two variables. The correlation implies causal relationship. For example, when we say that there is high degree of correlation between rainfall and crop yield, we mean that when rainfall increases, crop yield also increases. Now, if you can find the relation between the crop and the rainfall, so when the rainfall increases, the crop yield also will increase. So rainfall is the cause and yield is the effect. So there is a cause and effect relationship. The presence of a high degree of correlation between variables do not necessarily mean the existence of causation. There are many possibilities with regard to cause and effect relationship. Some of them are: two series of data may show high degree of correlation, but this may be purely accidental or through chance. For example, number of cars produced is increasing, the number of accidents are also increasing. So, even though they are not related, they both are increasing. So, the number of cars increases, the accidents also increases. Both the variables being influenced by the same external factors. Sometimes instead of one variable influencing the other, both the variables are influenced by an external factor. For example, the yield of rice and yield of wheat is increasing. This may be due to good rain or fertilizers used. Then another possibility is that interchanging of the cause and the relationship. Generally, increased price reduces the demand. So when the price increases, demand will fall. But sometimes under scarcity conditions, increased price may also have increased demand. So people may purchase more thinking that it is not easily available. When the commodity is a scarce commodity, people will think of purchasing more because of the scarcity. Thus, mere presence of covariation between two variables is not a conclusive proof of causation. So, correlation indicates the existence of association of variation. So, it is clear that correlation does not always imply cause and effect relationship between the two variables. So, according to Croston and Cowden, the coefficient of correlation must be thought of not as something that proves causation, but only a measure of covariation. But the cause and effect relationships involved must be by a process of scientific reasoning. So, this cause and effect relationship should be the effect of a scientific reasoning. Then, the study of correlation is immense in practical life. With the help of correlation analysis, we can identify the direction or nature of relationship between the variables. So, what is the kind of relationship between the variables? We can know with the help of correlation. Then, we can measure the magnitude of degree of relationships existing between the relationships. So, what is the degree of relationship they have? So, if it is above 90%, then it means they are closely related. If it is below 50%, that it means that it is not so very connected. We can identify the independent and the dependent variables. Average relationship can be summed up in a single value of change called coefficient of correlation. So, average relationship can be summed up in a single value of change called correlation coefficient. Then the concept of regression is based on correlation, which is used for prediction or forecasting purposes. Now, this regression is used for the basis of prediction and forecasting. Next, let us have a look into the types of correlation. So, based on different criteria, correlation is classified into different types. The first one is the positive and negative correlation. Second one is linear and non-linear. Third one is simple, multiple and partial correlation. The last one is spurious or nonsense correlation. Now, let us see what is this positive and negative correlation. So, the direction of variation of the variables determines whether the correlation is positive or negative. When the values of the two variables move in the same direction, that is, an increase in x is followed by an increase in y, or a decrease in x is followed by a decrease in y, then the correlation is said to be positive. Suppose in the x values, if x increases, y also increases, then we call it as positive correlation. Then if x decreases, then y increases, then we call it as negative correlation. When the values of the two variables move in the opposite direction, that increase in x is followed by decrease in y, then the correlation is said to be negative. So, this is positive, this is negative. Then, if the amount of change in one variable tends to have a constant ratio to the amount of the change in the other variable, then it is said to be linear or perfect. Now, suppose the x and y variable, here there is a 10% change, here also we have a 10% change, then we call it as a linear correlation. If the amount of change in one does not bear a constant change in the other, then it is said to be non-linear. Suppose here it is 10%, but here it is only 5%, then we call it as non-linear. Then when only two variables are studied, it is simple correlation. For example, relation between rainfall and yield. So, when you study rainfall and yield only, then it becomes simple correlation. When more than two variables are used, then it becomes multiple correlation. Then, spurious or nonsense correlation. When there is correlation between two variables, it may be that the variable is the cause of a change in other. There is a covariation based on some logical relationship and causation. Sometimes even if two variables are independent of each other, there is a high degree of covariation between them. Such covariation between unrelated ones, we call it as spurious or nonsense correlation. Then, methods of studying correlation. We have the graphic method. So, in this we have the scatter diagram, correlation graph, and mathematical methods. We have Karl Pearson's coefficient correlation, Spearman's rank correlation, concurrent deviations method. Now, in this, first let us see what is the scatter diagram. So, it is a dot diagram and it is a chart prepared to represent the relationship between the two variables. The rules of plotting the dots are the same as in the case of the line graphs. The variable x is shown on the horizontal scale and y on the vertical scale, and only one dot would be marked for each pair of two values. So, this is the scatter diagram where we can see. So, the x values here, y values here. So, this is what we call as the perfect positive correlation. So, both are in the same direction. Then perfect negative. So, here also negative direction. Then low degree of perfect. See, if you can see, the dots are not in a straight line. So, this is a low degree of perfect correlation. So, if you can see here, the plots are in a circle. So, there is no line here. This is no correlation. This is also no correlation. Then, next one is the linear positive correlation. So, this kind of a correlation will help us to know whether both the variables are moving in the same direction. Then, nonlinear negative, this is where both of them are falling down, and if you have a curve like this, then we call it as a nonlinear correlation. So, this diagram will help us to know what kind of a correlation it is. Then, next is the correlation graph. It is also called as a parallelogram, where variables are given with reference to time. The values of the two variables are plotted on a graph paper to get two curves, one for each variable of x and y. The direction and closeness of the two curves shows the absence or presence of correlation. If the curves are parallel, moving in the same direction, upward or downward, the correlation will be positive. But if they move in the opposite direction, the correlation will be negative. This method gives only an approximate idea and not the exact degree of correlation. Now, when you plot the values in a correlation graph, you can just observe how the values are. So, we saw here how the values are. So, in this, either it may be like this or it may be in the form of a curve. So, we can just observe the values there. We cannot measure the degree of correlation. Then, so here there is one example here. In the year 2007 up to 2016, they have given the income and expenditure in lakhs. So, this is the illustration problem which we have to plot it on the graph here. So, in this graph you can see here, in the x-axis we have the years from 2007 to 2016, and then we have the income and expenditure graphs here. So, if you can see here, the income is 100 in 2007, whereas the expenditure is 90. So, here income is 100, expenditure is 90. The next one, if you can see here, income is 103, expenditure is 92. Income is 103, expenditure is 92. Then 105, 94, 105, 96. So, 105, again 94, 105, 96. So, if you keep on plotting, so we are getting this curve which is the income curve and this is the expenditure curve. So, in this way we can see that the correlation values they are plotted on a correlation graph, or we call it as the parallelogram. So, With this, we can see how both the graphs, the lines on the graph, they show that there is a slight increase in the values depending on the income. So the expenditure also, we see a gradual increase in the expenditure. So in this way, we can say that there is a relationship existing between the income and the expenditure. With this, we come to the end of this session. Hope you have all followed it. Thank you.